I'm going to show you how to connect a really cheap kettle to the factory in a box. Well, maybe before I do that, I just want to note that there's been absolutely no connection to any of the higher voltages or any of the lethal voltages on this kettle at all. It's just literally screwed to microswitches to the base, and these represent the sort of the lowest cost sensors potentially we can have. Let's show that to the camera. So if we have a microswitch that's going to sense when the kettle is switched on, and this microswitch is going to sense when the kettle is on the base. Okay, we're ready to go. We've got our new node connected. We're powering it from the wall. We've got our channel, our common ground, and our two channels for the two switches set up. DIO 0 and DIO 1. We've got DIO 0 on the switch on the back of the kettle and DIO 1 on the base. That way around really for just preference in the sense that which bit changes the quickest we've got on the least significant bit. We'll also see later on that we've got this set up for essentially negative logic. Right now those inputs will be at 1-1. We've used pull-up resistors here because we're just using switches, and the switches ground through their internal pull-ups to 0 volts. Okay, let's see how it looks in Node Red. We've got a webcam showing the base of the kettle with the two switches visible and XBee, and we have a completely blank editor from Node Red. So let's add some nodes. We need an IoT XBee input, a receive. If we just hover over it, we'll see that it says it's intended to continuously receive data. We've also we get some help on the right hand side here. We'll have a debug message. We'll have a debug node to see what we can see what message properties we want, and we'll wire them together with our mouse. We can see that the XBee is not configured, no properties set. Let's add a new XBee configuration. Now we're going to use API mode 2. We need to know the serial port. Which is dev TTY USB 0. We need to adjust the baud rate, and just obscured by the webcam, we're just going to look and put RTS CTS flow control. We'll add that node and we'll say we're done. Okay, nothing's happened yet because we need to deploy. Let's go to the debug screen. Let's deploy that straight away. We'll see that our XBee is now listening. Okay, let's trigger an input. So it's completely event driven, so every time there's an event we get a message. Let's unpack these messages, see what we get. Remember, this is our switch at the back we pressed first, and we see that gets us a result of 1, 0. If we open this one up, when we let it go, we'll see we get 1, 1. The second switch, we'll see we have the data as 1, and again when we release that switch as well, we'll see that the data here is 1, 1. Now what does all that mean? We need to turn our bits into information that's meaningful for us. Let's make that webcam a bit bigger, and we'll see what's happening. So let's take a look at our switches. We've got DIO 1 and DIO 0. Now we do have a state where we're using sort of negative logic. Right now those switches with the pull-up resistors on this device are both reading 1 each. So let's try and put all the different states that we can possibly have on this diagram. So if that one's 1 still, this one's 0, and that one's 0, 0, 1, 0. So these are all the states that could possibly exist. What do they mean? Well, this first two potentially mean that the kettle is off the base. So that's the base. And this one is the on-off on the kettle. That's kettle on-off. So, if the kettle is off the base and the kettle's off, that's one here, so that's definitely off. Well, what about this state? This second one here? Well, to be honest, that would mean that we had some imaginary kettle, or we just made that switch ourselves. Now that doesn't mean much, so that's really no meaning, and it's sort of essentially a mask. That still means off, so we just don't care about that one. So in some respects we could replace those two with an X, that we don't care. These ones are more interesting. 0, 1 means that we have a kettle on the base, this switch is made, but it's not turned on. So we can call that idle, for want of a better word. What about this state? 0, 0. Well, for me, I think that's when our kettle is sort of boiling. So our kettle's busy, it's actually active. So now we have all 4 combinations of switches, and we have 3 relevant states. What we might want to look at is what they actually mean for colours, for example. And that's a whole nother story. Do we want to call busy that it's red? Do we call off red? Do we want to call idle green, for example? Or green for when it's active? Anyway, those are decisions that we need to make later on. But perhaps I might suggest that we might use red here, meaning off, for our display. Idle, we'll say it's green because it's ready to go, and we might use amber here for busy. Let's see how we can do that in Node-RED. I've made the webcam a little smaller, tidied up the drawing a little bit, and hopefully that will be there to remind us. And now we have to change what we have in Node-RED. Now ideally we want to use Node-RED's runtime. We want to see the dashboard, and right now we have no dashboard nodes installed on this particular one. Of course, on the factory in the box it's already there. So let's manage our palette and let's install a dashboard. Node-RED dashboards. Here we go. Let's just install that. It doesn't take very long, and essentially when we're in our manage palette, it allows us to add nodes that are contributed from the community or Node-RED nodes from Node-RED themselves, and that's all there is to it. So now on our palette we're going to have some dashboard items, button, drop down, etc, etc. Before we go on any further, I think I'll move the video across a little bit. That'll let us have a bit more space to show the info boxes. Okay, what do we need to do? I think we're going to use a text box or a text node that will display non-editable text on our UI. We're going to use a chart object too. They'll need configuring and they'll need setting up. Essentially, charts will take numbers and a text box takes text. We've determined what our text we want. We want off, idle and busy as text, And for the chart, well, charts have numbers, so perhaps we might think about 0 and 1 for the chart. And 0 is going to be referencing our off and our idle states, and 1 is going to be our busy state. We could perhaps have different levels of off, 0, idle 1, and busy 2, but we'll leave that up to you later on. But how are we going to get our message payload, which we know is in this format? How are we going to simplify it to get it into a state where we want? Let's have a look at what these boxes require. Well, the text box is going to require message payload to be essentially what the value is that's going to be displayed. And in this particular case, I would imagine the chart has the same thing. The chart requires message payload value. Okay, we'll quickly configure those. Let's look at the chart object. Line chart will be fine. User interface group, well, we'll leave that as the group as home with the tab as default. 6 width, we'll display that. We'll say add that one, and then the chart's going to be in that home group. We'll make it a step chart. We won't have any legend. We'll display, well, on the last minute, for example, here, and that'll do. The text item, well, add it to the default group. The label we'll call status or state. It does take formatting. We might as well format it right now. We'll make it a heading 2. And we'll deal with the value later. How about the logic, though? We need to get our payload information, which is in this form initially, our digital samples array, to a state we're going to add into our chart and our text box. For that purpose, we're going to use some of the functions. We're going to be using the switch and the change functions, which will mean that we don't need to write any JavaScript. We're going to use a switch node, therefore, and a change node. We'll use multiple change nodes for each of the chart objects, or each of the objects we want to plot on the chart, and also for the states that we want to create. Because, as I say, they're going to require different states, or sorry, different message payloads. So the switch function. Let's configure the switch function. Well, the property is not message payload that we need to set or change. We're going to look at a property of the digital samples array, and we can copy that and we can paste it in here, and we can, it's an array. We need the first object, and based on what it is, we're going to change the outputs. That's what the switch does. The switch will allow us to switch these outputs. So let's look at what we have to do. So when it's equal to, well, we've got a choice of values here, or it's a string, and we're going to see that we have a string value of, in this case, 1 1. Well, we'll start with the original, or the lowest one. We'll add 3 more, and so when it's 0 or 0 1, which comes at 1, or 1 0 or 1 1, then that's going to be our changed our switches. Sorry, these are our switches. So let's look at, we want to try and add some labels to this. Let's look at its appearance. So we'll use the input, we'll call that the XBee input, and we'll use the outputs, we'll use them as, and we'll label them to be our levels, so 0, 0, 0, 1, 1, 0, and 1, 1. And bear in mind the output order. We might need to reverse that, but let's live with that for now. So now we have a switch with our labeled outputs. If you want to move them around, I think we can just pick them up and change them around. I hope the labels go with it. Yep, they have. So now we have our switch. And we need to set a payload after we've switched it. So let's create a payload for our chart. So what does this one do? Well, we set the message payload to a particular value based on an input rule. So we'll say, what should we call it? Payload equals 0. Let's put a number in there. And payload equals 1. We'll copy and paste. Let's rename it. So we have two different levels of payload, 0 and 1. Now 0 is going to equate to when the state of the XBee is, well, in fact, all those three levels here. So that's going to be a 0, 0, 0, and that's going to be a 1. So all we're going to do is connect the top three to payload equals 0 and the bottom one to payload equal 1. Alright, we'll deploy that and let's see what it's like on the dashboard. Refresh that. We have a chart but with no data. That looks about right. Let's just check what we've got here. We've got some words in here, default, we've got state, we've got chart. Let's refine that, let's tidy the chart up. Let's give it a min value of 0 and a max of 1. We've got some group names. Well, let's see if we can edit that on the dashboard. At home, we've got default. We'll edit that. We'll call it kettle. We'll update that. Deploy it. Check the dashboard. Now change it to call it kettle. That's great. So our chart's behaving itself. How are we going to change our state? Our text box. We'll use the same switches. but we'll need some more of these payload objects. I think we should be able to paste that already. We're going to need, we'll give it a sensible name first. We'll change the payload to the text busy. We'll change that to idle. I'll change that to off. We'll wire them in. So off is 1 1 and 1 0. Idle is 0 1 and 0 0 is busy. They need to go to our text box. Let's deploy that. And let's check the dashboard now. We need to change the state in order to see a change. So we have idle, busy, idle, and off. Off isn't showing. So we obviously made a mistake somewhere. Let's do some troubleshooting why we haven't got our off state. I would imagine it's because I forgot to configure this. Okay, here we go. We can see there's a red box around here. It's actually a string. So let's do that. It's not deployed. We can change how we deploy, whether it's a full deployment, modified flows, or modified nodes. Let's just click on that one. So we just updated that node. Let's see what state we're in. Now we have the off state. Idle, busy, idle, off. We talked before about formatting. We want to try and get some formatting in there. We'd like to see some of our colours. So how do we introduce colours to our state? Let's go back to our box here. Let's look at our information. And it tells us that we can, actually the value format field can be used to change the displayed format and can contain valid HTML and Angular filters. Well, we already used a filter in the, a HTML tag in the for the label. And maybe put a colon in there as well while we're at it. But we want to do the similar things for the payload. We're going to use a heading tag. And we'll use an older font tag as well. And that will allow us to change the colour. So let's just look backwards a little bit. So we have font, colour with the American spelling equals. And we're going to use, because we need it to be different for everything, we're going to use another Angular filter, and that's with those double mustaches essentially. And we'll create a new message object called a message color, and we'll spell it in Australian English, and we'll use that in here. So as well as that, we'll set message color to, for busy, I think we want orange, which is close enough to amber. idle, we wanted a nice green colour. I think we'll use, it's called lime, it's a brighter green. And off, we're going to use red. And let's deploy that. Let's look at our dashboard. We'll trigger a state change. And here we see we've got off in red, idle in green, and busy in amber for our kettle object. And that's all there is to it. We have now created a dashboard with one tab, with one chart and one state for our kettle. And we've done it without having to resort to writing any code, any JavaScript code. We've used our switch node function and our change node function. We've used a chart object, or a chart node I should say, and a text node, a text output node. If we notice on the colours, these ones are slightly darker, sort of turquoisey green, and they tend to be sort of outputs. We can even have some audio. In fact, just for a bit of a bonus, let's see what the audio sounds like. We'll really just have the audio output. How do we configure it? We need a voice by the look of it. We'll have Hazel. Done. Deploy. We've left it so that play audio when window not in focus. We've got that unchecked. Let's just see how that goes. We might not pick it up because it's going to be, well, we might pick it up on the microphone. I got a feeling it's going to be on the audio output from the computer. But let's have a listen.
Idle. Busy. Idle. Off.
There we go.